Thank you everyone for coming out today, all of you. My name is Dennis Henry. I work with Hosttime.com, which is a locally owned and operated data center company. But we're actually a global corporation that was founded back in 2002. Today we're going to be talking about cloud storage and data center management. And we actually brought some cool props to show you guys a little more about what the cloud is and how it's actually ran on a much more real level than what you may see in marketing material or on TV and commercials and such. So, like I said, Hosttime is a privately owned and operated data center provider. We offer managed cloud hosting services, which are fully supported amenities and web tools that empower global users to do pretty much everything they need to do on the internet. Hosttime is globally recognized as an established, reliable, and trustworthy data center company in the industry. There are a lot of companies that do what we do. Some that you may be more aware of are companies like GoDaddy. Obviously, they have the race car, and they have much better advertising than other companies that do what we do. But we are different in the essence that we're actually a privately funded company, founded here in Orlando, and then we grew internationally. We have branches across the globe. We have a branch in Mexico, Colombia. We have a branch in Brazil, which is actually a very large branch, in India and the UK. So these are all globally operated data centers that basically fully function on their own separately from Hosttime US, but we all work together to kind of achieve the same goal, which is to have great services that our clients can rely on. In 2003, we opened our first data center here in Orlando after growing from 1 server to over 200. From there, we've grown even further. Passion and vision is what really have driven us and prompted our founding engineers to design our own facility, which provides the highest level of uptime and service to our clients. We currently offer products like managed dedicated servers, managed VPS, colocation, and we have managed OpenStack cloud. These terms may be very kind of high level to you guys, but basically it all breaks down to what you see up here, which are servers. These are, every website you go to on the internet is stored somewhere physically on a server just like these. These are just 2 examples we brought to show you guys, and I'll go into more detail about them later. So, kind of to gauge the audience a little bit, what is your guys' current level of knowledge about data centers and the cloud? A little bit? What all have you heard, or what do you know so far about data centers?
Really minimal.
Minimal?
You'd have to give me 101.
Yeah, well that's good. That's what we're here for. Anyone else? You, sir?
I am the least technically advanced person in this room.
Okay. Well, that's good. I mean, I'm doing this presentation as a way to try to expose you guys. If I ever say something that's a little too high level, just stop me, ask a question, put up your hand, and we'll do obviously a Q&A at the end too, to kind of address any of your concerns that I didn't hit in the presentation. So, what is a data center? That's obviously a good first question. A data center breaks down to really being a telecommunications hub. It's a place where the internet comes together and you are able to go and access a site. When you type in google.com, you're going to a data center somewhere. Obviously, Google, you may be hitting one, God knows where. They have many, many, many data centers, and they're globally kind of geolocated, so wherever you are, you hit their closest data center. But you may be hitting our data center, and if you're using a local website, hopefully you are. There's hundreds of gigabits, which is a unit of measurement for data of bandwidth, which is how much data can be flown or flowed through the available internet space that a data center has. We house, our data centers in general, house hundreds to possibly thousands of powerful servers just like these 2 in front of you. DimeKnock specifically, our data center here in Orlando, over in actually in Eatonville, houses over 6,000 of mainly servers like this, but spans to servers just like that one as well. Some of the big key differentiators about data centers is the fact that rather than having one of these sitting in your home like you may have a home computer, our data center has redundant power and cooling to keep us up, as well as internet connectivity. So if we get hit with, say, a storm, like Tropical Storm Colin, if we lost power because of that, like many, many people here in Orlando did, we would stay up because we have UPS battery backups, and then we also have generators that'll turn on and keep us going for days on end, and then we can always refuel them. They keep on going, and we have contracts and that kind of thing. So that's what kind of differentiates data centers, is how much of that backup they have. Some data centers only have one little generator or one little UPS and may last a day. Good data centers like ours, we have 2 UPSs that are both in tandem. That way if one fails, we still got the other. And we have 2 generators, both in tandem. That way if one fails, we still have the other. N+2 is considered an optimal level of actual failover ability. So obviously then you have this crazy term called the cloud. It's used, frankly, far too much in the world these days. The cloud is what you hear about online, what you see in commercials, etc. And this is really a definition. This is from Wikipedia, actually. Cloud computing is a colloquial expression used to describe a variety of different computing concepts that involve a large number of computers that are connected through a real-time communications network, the internet. That's a marketing BS definition, if I ever heard one, which is funny because it came from Wikipedia. What is it really? Like, let's get down to it. What is a data center? Or what is cloud computing? In practice, it's a marketing term that's meant to simplify a very complex topic, which is remote computing environments, which is the concept that rather than having to deal with a computer in your home, you can deal with a computer somewhere else. You can offload some of your workload. And this is really key, obviously, when you're talking about business, which is where we're going to go into it a little further on in the presentation. It's obviously enabled by the internet, and it mostly involves virtualized computing environments, which is not even just talking about the physical computing environment, which is a server, but in that, even further going down, you have virtualized servers within a server. It becomes kind of like a Russian doll set, if you guys have ever played with those, where you could have so many different layers of virtualization that it spans even further down. So, and you can even go, like I said, further down, virtualized applications, which are just individual little processes, just like you would run Word, a virtualized application on a virtualized server within a physical server. It gets, like I said, very Russian doll. And it has different uses by different people. The cloud does. So conscientious consumers have to do a lot of research regarding what a service provider means when they say the cloud. When we say the cloud, we may mean one thing. When another provider says the cloud, they mean another. What you may need is completely different from both those. It's a really kind of hard thing to get across to people because they're used to one thing meaning one thing, which sadly in the internet and in the digital age, one thing doesn't always mean what you think it means. So what is cloud storage? I mean, that was the title of this presentation. Cloud storage is a type of cloud computing. It's a phrase that separates the storage layer, meaning say you have a bunch of files, you may have a ton of pictures of your kids or grandkids playing, or for a business you may have tons of files for your human resources department or your clients invoicing, that kind of thing. It's separating out the storage aspect of the cloud from the cloud computing, which is the actual processing layer. And like I said, it allows offloading a large amounts of data from the dreaded IT closet. This is a good example of what sadly exists far too often. These are frankly accidents waiting to happen. They're typically underventilated, undercooled, and they created a terrible environment for servers to actually exist in. I've seen this time and time again when I'm dealing with clients and when I'm dealing with potential clients that want to offload their servers to us. We go into this closet and it is a sauna that a human shouldn't even exist in, let alone a server that needs to be running at peak optimal efficiency at good levels of cooling. So this is just an example, but this is what cloud storage enables you to get away from. Moving away from these closets full of servers and cables and heat generating things to a data center where you can offload that responsibility. So how does cloud storage work? It requires a large team of people to keep both the hardware and software running at peak efficiency. And that's, again, why you trust a provider like Hosttime or another provider to offload that. That way, rather than having to deal specifically with making decisions regarding your services being at peak efficiency, you can offload that to people that are specialized and know what they're doing. It doesn't magically stay out. That's one of the things that the cloud sadly tells people is that, oh, it's all magic. You throw it up in the cloud and it's gone, and you never have to worry about it again. It'll stay up forever. It's not like that. The cloud requires a lot of great minds that come together and plan out the cloud that they're setting up intelligently, and then monitor it 24/7, 365 to keep things running at all times. So once set up, cloud storage for the end user is basically transparent, to be honest with you. It doesn't require too much hand-holding from the user side, and that's maybe where the marketing term kind of gets involved and makes it feel like it is magic. Users can access files, modify documents as they would normally, just like you may open up an image or a Word document on your local machine. The same kind of thing can be done with a cloud storage object. Some cloud infrastructures can even allow for thin clients, which is a really cool concept where you actually have the ability to have an entire virtualized desktop environment away from the servers. So, for example, rather than having to have a full computer set up on your computer where you're up and running and kind of like the processing is being done right there, all you need is a very simple computer that only really has a CPU and a network connection, connects to the internet, and that's where your actual computer is on the internet in the cloud. It's a great way for companies to be a lot more agile with deploying workstations. Rather than having to buy full-fledged computers, they can have thin clients to just connect to their cloud and go from there. Most of the heavy lifting is done by network file systems, which is a concept where the file system is extrapolated away and becomes more of a network environment than it does a physical environment. Obviously, when you get down to it, it is physical, but for the end user, it becomes more of a network transaction. So servers and microservers. This is where we get more into the nitty-gritty of these two show and tell items, basically, up here. So a rack server. This is what one would really typically call when they say a rack server. What this server is it's a computer, just like the one that may be on your desktop at home or your laptop that you carry around with you, but it's dedicated for use as a server. And it's designed to be installed in a framework called a rack. A rack is a very tall, and you may have seen these, and I'll go into further detail about them, but a rack is a physical, big, typically made of steel environment for you to store these rack-mounted servers. They slide in using racks, and then they just connect in, and then you can use them in a more space-efficient manner. The rack contains multiple mounting slots called bays, which is what you would put this in, each designed to hold each hardware unit secured in place with screws. A rack server has a low-profile enclosure. As you can see, this is about 1.5 inches tall. Obviously, it's pretty deep. You've got about 19 inches of depth here. But in contrast to a tower server, which I'm sure all of you have seen, they're tall and just like the one that may sit on your desktop. Those are tower servers, which are mainly a thing of the past these days, other than on desktop environments. And even then, most people are moving to laptops. Oh no, there it goes. Microserver chassis. So these are a much newer concept, which is what we have over here. This is what's called a microserver. It contains a bunch of little servers like this guy. This is one of 8 that fit in this server. There's 12 bay micro chassis also, and I think they go even higher. But this is a miniaturized version of this big thing. And on the back, it has hard drives, which are what are up front in this one here. So this allows you to get even further density out of a certain amount of space. And at the end of the day, when you're talking about a data center, that's going to be one of your big things. It's trying to get as many servers into as little area as possible. Because that's how you get more efficiency, that's how you get more space usage out of your physical environment. Each microserver is a server in its own right, and it's dedicated to typically a single application. But then again, you can also dedicate it to multiple applications. It's really up to the end user. Microservers are literally just little servers on one card. And at the end, I'm going to have you guys come up here and look at these, obviously, because I know this is probably not very easy to see. So yeah, they have memory, they have integrated network controllers, they have everything that this big server does, but in a much smaller footprint. Microserver is sometimes referred to as a high-density server, and is typically used in clustering of servers that are dedicated to a single task, such as file sharing, website serving and caching, and then one of the big ones these days with streaming audio and video. Netflix, big providers like that, typically use microchassis just like these to be able to get as much as they can into their physical footprint as they can. Because that's where the cost comes in, is the physical footprint. Data centers are expensive to build, they're expensive to maintain. These allow you to get a lot more density out of that. So clustering servers. This goes back to the concept I was talking about earlier of how you can even chain this further down the line. Most cloud storage providers utilize cluster environments to allow for separation of services to prevent potential downtime. Better planned and organized clouds are more complex. And I have a really cool diagram I'll show you of how complex you can get. And they're more expensive to set up, but allow for much more agile updating. You can update a service or update a server and not really interrupt the end user's experience. You guys aren't going to have to worry about your Netflix streaming going down when they take one of these servers out and replace it with a new one, an updated one, because they have this clustering of services set up. A crucial aspect of clusters is the elimination of single points of failure, and this is something that transcends computing, it transcends a lot of things, a concept that you never want a single thing that can break that can affect everything. Single points of failure are a big detriment to any business model, especially in IT. And it's an individual piece of software or equipment that fails and causes system downtime for everyone, or data loss, which is probably the worst thing that could happen. In order to eliminate single points of failures, mechanism must exist for the redundancy of network components, databases, which are basically software-based places to store files and or store information in an organized fashion. Think Excel, if you're more aware of a desktop application, and storage components. Obviously, these physical drives that are called drives, or that are called, this one actually is this one's a hard drive, not a solid-state drive, but that actually store the data on either mechanical or nowadays it's more solid-state drives. So this is just an example of how complex you can get when it comes to a clustered environment. This is actually one of our clusters that we have in our data center. So you can see it separates out, say, the computing, and this is just a monitoring layer. This is a network layer, controller layers, which are the interface that the user is talking to the networking layer, which are the switches, the places where you actually plug in your internet to, just like you would at your house. Your balancers, which allow for the packets to flow between different places, again, to allow for that no single point of failure concept, to proxies, to data storage, to database storage. So this is all obviously interconnected in cabinets, which are where these live, and then all of these services run on various servers. But again, in duplicity to allow for the fact that we need to make sure that if one thing goes down, if one piece of software, one one installation of an application goes down, we're not down. And that's at the end of the day what cloud storage allows you to do. So this is just, like I said, a very high level graph. It gets way more complex. I had 4 other ones that were, I figured, maybe too complex to show up there. But this one is a nice, simple kind of visual concept. So that's all I had for the presentation.